Hello, this is Mr. Wynn, and this video is about transformations part 2. We're going to focus on rotations and dilations. So first, before describing rotations, let's talk about clockwise, abbreviated CW, and counterclockwise, abbreviated CCW. Clockwise is the direction a clock goes, which you know it goes to the right, so it goes this way. Alright, counterclockwise is the opposite, so it will go to the left. So it would go this way. Alright. In math, if a problem doesn't tell you which direction, you have to use counterclockwise by default. So think about it. If we use the quadrants, we've always gone 1, 2 on the left, 3, then 4. We've always gone counterclockwise. That's how math works. Alright, so using that, let's answer a few questions. It says 90 degrees clockwise. So make sure you know which way your paper is. The clock at 12 at the top. If I go 90 degrees clockwise, that means turn it right 90 degrees, just one turn. So it would basically be a sideways to the right. Alright, let's go back to the normal orientation. Now next is 90 degrees counterclockwise, so we're going to go to the left 90 degrees. Alright, so now the 12 is to the left side, so this is sideways to the left. There's a difference. Some kids make the same thing twice and get it wrong. Clockwise and counterclockwise, different things. Last, we're going to put it 180 degrees. It didn't tell us which direction, so you must assume counterclockwise. So that's going to go upside down to the left. Now, if you go 180 degrees clockwise or counterclockwise, they're both upside down. So technically it doesn't matter there. Upside down. Alright, knowing that, we now answer some other stuff. So, rotations are the spin and turn. Rotations simply turn a picture according to the angle and the direction. We usually use 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Now the shape and size stay the same, but the orientation will change. The pre-image and the image are still congruent because they can still overlap perfectly. They're the same sides and same corresponding angles. So again, like before, A, B, C, D, E is the pre-image in red, A prime, B prime, C prime, D prime, E prime is the image in blue. So if you notice on our picture, this is a transformation. It's just a rotation 90 degrees clockwise to the right. In words, just rotate clockwise 90 degrees. If you find the points, A prime was at A was at -7.4, A prime turned into a positive 4.7. Then E started at -5.6, E prime turned to positive 6.5. So how do they get these points? Technically, you switch X and Y, and then you multiply the X number by -1, because the X star turns positive. Alright, so that's the motion rule there, but that's only true for 90 degrees clockwise rotations. It does change depending on what the angle is and what direction you went. But for this, you flip the X and Y, the original Y becomes the new X, and the original X you multiply by -1 to get the new Y. Alright, so the motion rule again changes, so trying to memorize these, there's too many. Learn the process, it's pretty simple. 3 steps. The first one is turn your paper the correct angle and direction. Step 2, you write down those points. Those new points will be your rotated points. That's usually your final answer. The X and Y axis kind of switch, but do think about it. Use common sense. Remember, right is positive, up is positive, left is negative, down is negative. And then unrotate and plot. So down here it says rotate A, B, C, D, E, counterclockwise 90 about the origin. So I turn it counterclockwise to the left. So it starts in quadrant 4. If I rotate it left, it will end in quadrant 1. This is my final picture. I'm going to write all these points down. Notice these are now, don't look at these as the negative sign, but that's positive 2, positive 4, positive 6, positive 8, positive 10. These are positive, this is negative, this is negative. Alright, so make sure you think about it correctly. I'm going to label them E prime, let's do that one first. The new E is going to be at positive 3, positive 7. Alright, then look at the new A prime. It's going to be at positive 5, positive 5. The new D prime is going to be at positive 5, positive 9. Then the new B prime is going to be at positive 8, positive 5. And the last C prime is going to be at positive 8, positive 9. Alright, final step, unrotate and plot. So I put it back to normal. Plot my new points. I'll use blue. E is at 3, 7. 3, 7 is right here. That is E prime. A is at 5, 5, 5, 5's right there. D's at 5, 9. B prime is at 8, 5, 8, 5. And C prime, 8, 9. Now if I connect this, it's the same picture, just turned or rotated clockwise, sorry, counterclockwise 90 degrees. Same size, same shape, same angles and everything. Alright, and I'm not going to bother doing the motion rule, but if you compare them to the original, you'll see what happened. Remember, you switch x and y, and then you multiply one of them by a negative, so that's both of them. Alright, here's the next one. Rotate 180 degrees about the origin. So 180, without, is it clockwise? I'm going to turn it right, 180. That's my new final picture for my answers. I'm going to label all those points. D prime, that is negative 8, because that's left 8. And down 4. Alright, so don't make sure you know these are negatives, these are negatives. Alright, because a lot of kids can get that wrong. If I do the next one, let's do A prime next. Negative 8, negative 8. C prime, and you just in order you want. That is negative 5, negative 4. B prime, that is left 5, down 8. Negative 5, negative 8. Last time I've done E. E is at negative 10, negative 6. And sometimes I'll ask you on a test, like, what is the coordinate of E prime? They won't make you draw the picture. But it's nice to be able to draw it back, so I'm going to rotate it back. And then plot those points. Negative 8, negative 4 is right here. That was D prime. Negative 8, negative 8. That was A prime. Negative 5, negative 4. C prime. Negative 5, negative 8. B prime. Negative 10, negative 6. E prime. If I connect everything, it's the same shape like it's supposed to be. So that's good. Then you can find the side of it. Basically, rotating starting in quadrant 1 and then quadrant 3, we rotate at 180 degrees. Alright, one more. Rotate this 270 degrees. So 270. Didn't tell you what direction, so I'm going to go clockwise. So I'm going to go left. Here's left 90. Left 180. Left 270. Those are going to be my final points. So C prime will be at 1, 7. B prime will be at 1, 3. D prime will be at left 2, negative 2, up 7. A prime will be at negative 2, positive 3. And then E prime will be at left 4, up 5. Alright, basically you get the points, put it back, plot them, you're good. I won't waste time by plotting these. Alright, move on to the last type. We have dilations. That's a shrink or grow. Dilations reduce or enlarge a figure by the same amount. Basically, all points will be multiplied by a scale factor k. Although the shape stays the same, the size is not the same, so the pre-image and image are no longer congruent. Instead, they'll be similar. So here, A, B, C, D, E is the pre-image in red. A prime, B prime, C prime, D prime, E prime is the image in blue. Here, the transformation was a dilation by scale factor 2. Everything got doubled. So if you look at A, negative 2, 2, you times it by 2, you get a negative 4, 4. If you have a E, 0, 4 times by 2, you get 0, 8. Everything got twice as big. So this right here, this was what, 4 units? Like this is 8 units. All this corresponding size got doubled. Alright, so description words, dilated by scale factor 2. Motion rule, original x, y, just double the x, double the y. You must use the same multiplier for both x and y. If it's not the same, then it's not a dilation. It can't be 2x, 3y or anything like that. So the motion rule for dilations, again, is just x, y turns into k times x, and then k times y, where k is the scale factor. There's only one step, multiply each point by the scale factor. You can abbreviate as SF or just k. If the scale factor is missing, you got to calculate it using the fraction new over old. And if checking to see if two figures are a dilation of each other, make sure the same scale factor was used for all pairs of corresponding sides. If one's different, then that is not a dilation. Note, be sure to ignore the sign when determining if k makes the image larger or smaller. If the scale factor is larger than 1, the picture gets bigger. For example, 10, I'm multiplying by 10, of course it's going to get bigger. Multiply 3.5. I could do a fraction, 5 or 4. Some kids think all fractions are less than 1. No, if the numerator is bigger than the denominator, that is more than 1, because 5 or 4 is about 1.25. I could have a negative number, say negative 5. Although negative does something else, I'm just multiplying all the numbers by 5. It's getting bigger. All right, if the scale factor is less than 1, the picture is reduced. For example, it could be 0.67, or it could be 3/4, or it could be negative 1/3, or 0.9. All right, so those are all less than 1. Ignore that negative sign. Here it says dilate line segment LA by scale factor 1/2. The motion rule is if you have x comma y, you just multiply by 1/2. So it'll be 1/2 of x, 1/2 of y. So LA, well, L is at 2, 4. If I do 2 times 1/2, I get, let me use red, I get 1. If I do 4 times 1/2, half of 4 is 2. For A, half of -4 is -2, half of 0 is still 0. If I plot these two, look what happens. L prime is at +1, +2 right here. L prime, and then A is at -2, 0. That's A prime. If I connect this, this line is half as long as the other one. I can use 2 of these to overlap. So here's one of them. Move it again. Here's 2. 2 of these exactly fit. All right. There you go. Pretty simple. Here's another picture. Dilate triangle ABC, so it's not a line segment anymore. By scale factor of 3. If it's scale factor 3, that means multiply each thing by 3. So 3 times x, 3 times y. A was at 0, 1. 0 times 3 is 0. 1 times 3 is 3. B is at 2, -1. 2 times 3 is 6. -1 times 3 is -3. -2 times 3 is -6. And -2 times 3 is -6. If I plot all those points, I'll use red. A is at 0, 3. Right here. That's A prime. B prime is at 6, 3. 6, -3. So +6, -3. Then C prime is -6, -6 right here. If I connect this, it's pretty straight. That's pretty good. All right, notice that the triangle is 3 times bigger. The bottom side is 3 times longer than the other bottom side. The right side is 3 times longer than the other right side, and so forth. All right, final slide. We'll be able to identify the scale factor of dilations. Again, to figure the scale factor, you do the fraction nu over old. And you know nu has to have the prime symbol. So here's the nu point because it has A prime. That's nu. And here's the old. All right, make sure you check for x and y. All right, so the new x is 15. The old x is 3. Again, that's the nu over old. So if I reduce that, 15 divided by 3, that's 5. I'm going to check the other one for the y's. Nu over old. So the new y is -25. The old y is -5. Or reduce that, divide top by negative, divide negative is positive, and reduce by 5, you get also 5. 5 matches 5. Great. So this is a dilation. Scale factor of 5. Let's try the next one. Again, this is the new point because it has B prime. Here's the old point. New x over old x. That reduces to 1/2. That's fine. It's getting smaller. Then for the y, the new y over the old y, that isn't reduced. They do not match, so this is not a dilation. All right, last one down here. C prime, that's new. C, that's old. New x over old x. You need to write this new over old. Reduce that. That turns to 2/3. Divide top one by 4. New y over old y. A negative is positive. Reduce the top and bottom by 6. You also get 2/3. 2/3 matches 2/3. Great. So this is, yes, a dilation. The scale factor, so SF for K, is 2/3. So you got smaller. It's less than 1. That's for the video. Hope you enjoyed watching it. Make sure you ask any questions in class. Thanks for watching. See you soon. Bye.